Hi everybody, this is Shiva signing in, and in today's session I am going to explain you about the amplifiers, especially common emitter amplifier circuit. So common emitter means here in this particular configuration the emitter is going to be used as common for both input and output. Amplification in the sense given a small signal that is going to be amplified into a large signal. So that is the meaning of amplifier, and let us see how this common emitter amplifier is going to increase or is going to amplify the given small signal to large signal. So we are going to have the operating principle of CA amplifier, that is common emitter amplifier. Let me explain you the common emitter amplifier circuit. For this we are going to consider an NPN transistor. This has got three terminals. Let me brief the NPN transistor we are going to use here. This is base terminal, emitter terminal and collector terminal, and the direction of arrow indicates the direction in which the base to emitter junction is forward biased. From this we can say that this particular transistor represents NPN transistor. The collector is N type here and base is positive, and again emitter is again N type. This is the configuration or connections which we have to give for this particular CA amplifier. Here VBB, V suffix BB is the biasing voltage for the base emitter circuit, and this is the AC signal, small AC signal which is to be amplified, and VCC is the voltage which is connected, biasing voltage connected in the collector circuit, and this will be in reverse bias mode. Means the negative terminal of VCC is the supply voltage which is given to the common emitter, collector and emitter circuit. Here this junction is going to be reverse biased for this particular amplification purpose. That means the collector is going to be connected to the N-type collector is going to be connected to the positive terminal. The output is going to be considered at RC. RC is the resistance which is used to collect the output, to receive the output signal. Here the total collector currents, it has got two parts. So it can be written as I suffix capital C is equal to IC plus capital IC. Here this IC component is going to give us the AC collector current which is due to the signal, and this IC, capital IC, is going to give us the zero signal collector current. It means to say that when the signal is not given, whatever DC current is which is going to flow through this collector circuit is considered as this particular IC. Hence the total collector current is the combination of these two components. One is AC collector current and another one is the DC component, that is zero signal collector current. And output is going to be considered as the product of whatever current passing through this particular resistance multiplied by this current. Here you can observe that the collector current is going to flow in the opposite direction. Actually this is the direction of flow of current IB coming from this input signal, whereas the IC is going to flow in the opposite direction. So when you consider the product or the voltage across this particular output, this will be the positive sign and this will be the negative sign, and if you draw the waveform, this will be exactly in 180 degrees out of phase with respect to the input signal that is given, that is to be amplified. So when you go for the circuit details of the CE amplifier, you know that the weak signal is applied between the emitter base junction. Always this emitter base junction will be forward bias irrespective of the signal that we are going to apply. The output is taken across the load resistance, already we have discussed here. So VBB is the applied voltage in the input circuit in addition to the signal to keep the emitter base junction forward biased regardless of the polarity. And VCC is the applied voltage to reverse bias the collector base junction. the transistor is biased to operate in the active region. As you know well, the transistor has got three regions depending upon the characteristics, like active region, saturation region, and cutoff region. And for this amplification purpose, we have to operate the amplifier in active region only. So when the input signal is applied, the base emitter voltage varies with respect to the time. So as the base current IB varies, the collector current also varies, and hence the output voltage also is going to vary. And depending upon the magnitude of the resistance that we are going to use, generally this will be very high resistance we are going to use. Depending upon that value, the output is going to be amplified with respect to the small signal. Here the amplifier, the main purpose of this transistor is going to be, it acts like a switch depending upon the signal, whether it is going to be positive half cycle or negative half cycle. So let me show you the waveforms. Here we are going to have the input signal as a very smaller one, and once it is given as the input, we are going to have the inverted. So here if you observe this amplified output waveform, it is going to have 180 degrees out of phase with respect to the input. So the reason already I have explained to you, because the current collector current IC is going to flow such that it will be out of phase, 180 degrees out of phase with respect to the input signal. Now let us see the output voltage which we can collect from this particular amplifier. Basically we are going to have two ways by which you can measure the output. Here the first one is to measure the output at this resistance RC. This is another method of connecting the circuit in order to get the amplification. And the output that we can have across the terminals 1 and 2. Here CC is the capacitor which is connected in the collector circuit, and the purpose of this capacitor is to block the DC component of the output voltage. Now let us see how these two values are going to be the same. Means if you measure the output at this RC, and at the same time if you measure the voltage at 1 and 2 terminals, how these values are going to be the same. Let me explain you. First, if you consider the output across this particular resistance RC, so IC is the current passing through it, and RC is the resistance value. So the output is going to be equal to IC multiplied by RC. So at RC the output is going to be equal to IC multiplied by RC. And if you measure at 1 and 2, so here at 1 and 2, if you write down Kirchhoff's voltage law, we are going to have VCE is equal to VCC minus IC into RC. So this is actually the supply voltage, and from this supply voltage, if you subtract this particular voltage drop, we can get the voltage across the terminals 1 and 2. So VCE is equal to the equation that we can write using Kirchhoff's voltage law, VCC minus IC into RC. But as the capacitor is going to block this VCC, we are going to have VCE as equal to minus IC into RC. So here at the RC, if you measure the output, the magnitude is going to be the same as that of the voltage which is being measured at the terminals 1 and 2. So the only thing is the magnitude is going to vary, the sign is going to vary, whereas the magnitude remains the constant. So this is how we can measure the output from a CE amplifier. Actually this type of receiving the output is going to help us when you consider the multi-stage amplification process. That is the reason why we are going to have the receiving of output like this. So that's all for today's session. So do subscribe to my channel, like, share, and your views and feedback, and click the bell icon for further notifications. Thank you very much. This is Shiva Biram signing off.